Good morning everyone. So today we are going to discuss sp3 hybridization. As I told you above, what is hybridization? Hybridization, that means this process of mixed and redistributions of atomic orbitals of same energy and symmetry to form of new sets of orbital. It is called hybridizations, right? And then we discuss sp hybridization and sp2 hybridizations. First sp hybridization is we discuss the example of beryllium atoms that it have a sp hybridization like 1s and 1p hybrid orbitals with single unpaired electrons get attached and give a same energy and same orbitals, that is called sp hybridization. And another one is sp2 hybridizations. The shape of sp hybridization is linear and the shape of sp2 hybridization is trigonal. We discuss the example of bf3 boron, right? That f orbitals attached to boron and give a trigonal pyramid. In 1s and 2p orbital mix together and give a new sets of hybrid orbitals. It is called sp2 hybridization. Now today we are going to discuss sp3 hybridizations, and sp3 hybridization, the shape of this hybridization is tetrahedral hybridizations. Okay. Now one s orbital and 3 p orbitals combine together to produce equivalent type of orbitals, and that's why sp3 hybridization take place. એટલે કે 1s અને 3p ઓર્બિટલનું મિક્સિંગ થઈ અને જે હાઇબ્રિડાઇઝેશન થાય તો એને શું કહી શકીએ આપણે sp3 હાઇબ્રિડાઇઝેશન્સ, રાઈટ? When 1s orbitals and 3 p orbitals combine together to produce equivalent type of orbitals, right? This is called sp3 hybridizations. Now 4 sp3 hybrid orbitals are produced which have the same energy and shape and are oriented at the angle of 109 degree and 28 to one another, right? When for sp3 hybridized orbital are produced which have the same energy and shape and are oriented at the angle of 109 degree to one another. And this is also known as a tetrahedral hybridization. Because why it is called tetrahedral hybridization? Because hybridized orbitals are oriented towards the four corners, right? એટલે કે 4 કોર્નર ઉપર એ આજુબાજુ થઈ અને ટેટ્રાહેડ્રલ શેપ આપણને બનાવશે અને વિથ ધ ન્યુક્લી ઓફ સેન્ટર ઓફ tetrahedron. Now what is the shape? Okay, this is also known as tetrahedral hybridization. Why tetrahedral hybridization? Because the hybridized orbitals are oriented towards the four corners. The four corners of tetrahedron with the nucleus occupying the center of tetrahedron. Right? So in this position, hybridized orbital have a minimum repulsion force. For example, we can take a figure. Now what is the shape? This one 2s plus 2px, 2py and 2pz, because here we are going to discuss sp3 hybridization. That means 1s and 3p orbitals can participate in this hybridization. So we can take 2px. This is called 2px plus 2py. This is called 2py. Another one is 2pz. Right, this type. And these all are combined. This is called sp3 hybridization. Right? So the shape will be tetrahedron. 4 sp3 hybrid orbitals. Right? So we are going to take a methane, that is called CH4 atomic number. Shape of methane, molecules, and atomic number of carbon, that is 6. You all are know, right? Now what is the electronic configuration of carbon in a ground state? That is 1s2, 2s2, 2px1 and 2py1, right? But in excited state, 1s2, 2s1, આમાંથી એક ઇલેક્ટ્રોન ક્યાં જશે? 2pz, જેની પાસે અહીંયા શું છે? 0 ઇલેક્ટ્રોન્સ છે, રાઈટ? 2s1, 2px1, 2py1 and 2pz1. And now in CH4, these 4 hydrogen are joined here 1, 2, 3 and 4 and give a sp3 hybridization. These are 4 orbitals having unpaired electron, right? બધા ચારે 1, 1, 2, 3, 4 આ ચારે ચાર પાસે કેવા છે? unpaired electrons છે, right? pairing માં નથી, unpaired electrons. And these 4 orbitals will first hybridize. So it is a case of sp3 hybridization. 4 hybridized orbital tetrahedrally are shown in a figure that I have drawn here. Now there is a C carbon, 1H here, 1H here, 1 here and 1 here. It is called tetra, and these all bonds are pi bonds, right? And this angle is, as I told you, 109.28. This type of carbon here, hydrogen, 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 so hydrogen, and here also hydrogen. So this is R in a hydron tetrahedral shape. Like this. And this angle 109.28. Right? So it how it's shown in orbitals like this. Here carbon, this is 1, and these 2 are like this type, and here 1s, 1s, 1s and 1s, right? This is called sp3 hybridizations. આ બધા કયા છે? H atom, H, H અને H, right? The shape of methane is tetrahedral, like this. Okay. Now another type of hybridization, this is called sp3 dehybridization. That mixing of 1s, 3p and 1d atomic orbitals gives 5 sp3d hybrid orbitals, and process is called sp3 dehybridizations, right? Mixing of 1 s orbital, 3 p orbitals and 1 d orbitals, right? Gives 5 sp3d hybrid orbitals, and it is called sp3 dehybridization, right? એટલે કે 1s 3p અને 1d ઓર્બિટલ ભેગા મળી અને આપણને 5 sp3d ઓર્બિટલ્સ મળે, જેને આપણે શું કહી શકીએ? sp3 dehybridization. And these are directed towards the corner of the trigonal bipyramid. Shape કેવો મળશે આપણને? Trigonal bipyramids. Before we discuss shape, first we discuss about electronic configuration. Now we are going to take an example of pf3. pf3, right? Now here atomic number of phosphorus no atomic number કેટલો છે? 15, right? And its outer electron configuration in the ground state is 3s2 3p3. For phosphorus, ground state. What is electron configuration? 3s2 3p3, and here we can take also 3d. So in 3s2 માં 2 electron, d ની 5 હોય છે, બરાબર, બધાને ખબર જ છે. અને આની પાસે 1 1 unpaired electron. Now phosphorus in excited state. So these electrons are going to promoted into 3d orbitals like this. Right? So આપણને sp3d hybridization જોવા મળશે. અને from 5 atoms, sorry, pf5, right? Here we can take pf5 because we have 5 orbitals. So what is the hybridization of pf5? Right? And આ બધા electrons કોના હશે? F ના હશે, right? Like this. This is called sp3d hybridization, right? In order to have this number of half-filled orbitals available for hybridization, so what is the purpose? 1 and 3s electron is made up of jump to a 3d empty orbitals, and thereby giving rise 5 half-filled. This is 5 half-filled orbitals, right, for the bonding purpose. And these 5 hybrid orbitals hybridize sp3d orbitals. This. So now 5 orbitals are available to combine with, permit the formation of covalent bond with 5 fluorines atom, right? But all the hybridized orbitals are not equivalent, and these are oriented towards the 3 corners of an equivalent triangle, making the angle is 120 degree. How? I will show in a figure. So in order to have a number of half-filled orbitals available for hybridization, in order to have number of half-filled orbitals available for hybridization, purpose 1 of the 3s electron, what will 1s of the 3s electron is made up of jump to 1 of the 3d empty orbital, thereby giving 5 half-filled. So we get 5 half-filled orbitals for bonding. And these 5 orbitals is called sp3d hybrid orbitals. Now what is the shape? Like this. here phosphorus, and we have a 5-fluorine. This one is here, another one is here, is here, and like this, F and A. So this is called, and this angle is 90 degree and this angle is 120 degree, and these all are the fluorine atoms like this. So the bond formed by these orbitals are known as equatorial bonds, and remaining two orbitals are oriented at the right angles to the plane of first set of three orbitals, and this PF3 is a trigonal bipyramidal shape. What is the shape? Trigonal bipyramidal shape. So this is all about sp3d hybridizations. Six equivalent sp3d hybrid orbitals is directed octahedrally. The shape આનો કેવો હશે? octahedral, right? We have an example of SF6. SF6. A number of sulfur, atomic number of sulfur is 16, right? And outer electronic configuration of central atom in a ground state is what is 3s2 3px2 3py 3pz, sorry, 1 and 2, like this. So 3s2 here 2 1 and 1, like this orbital by mistake. So this 3s electron is get promoted to into here, and this is here, like this, 2 electrons. So as in an excited state, it gives one and 1. So D have a 2 unpaired electrons, right? So 6 electron of 6 F atoms joined in this. So like this. So all are F atoms, right? So this is called sp3d2 hybridization, and these 6 orbitals hybridize in a sp3d2 type, and the 6 hybrid orbitals are now directed towards the corners of regular octahedron. Now what is the shape? This is octahedron. How? Like this. Here central S, F, F, and F, and this is like this. Right? In other way, how the bond is formed by like this, right? And this is also here oriented, this is here, like this. Here also. This is called sp3, sp3d2. And another we have also example of xenon f4. Xenon is a noble gas and its atomic number is 54. So in the xenon we also take place a sp3d2 hybridizations.